Philosophy of science is the study of the assumptions, foundations, and implications of natural science, which is usually taken to mean biology, chemistry, physics, earth science and astronomy, as opposed to social science which deals with human behavior and society. It asks questions like, what is science, what are the aims of science, and how ought we interpret the results of science? Scientism is the broad-based belief that the assumptions and methods of research of the physical and natural sciences are equally appropriate, or even essential, to all other disciplines, including philosophy, the humanities and the social sciences. Positivism is the closely related philosophy which holds that the only authentic knowledge is scientific knowledge, and that such knowledge can only come from positive affirmation of theories through strict scientific method, which means the collection of data through observation and experimentation, and the formulation and testing of hypotheses. One of the central questions in the philosophy of science is distinguishing science from non-science, although many regard the problem as unsolvable or moot. Historically, the main point of contention was between science and religion and, even today, many opponents of intelligent design claim that it does not meet the criteria of science and should thus not be treated on equal footing as evolution. The criteria for science typically include the formulation of hypotheses that meet the logical criteria of contingency, not logically necessarily true or false. Falsifiability, capable of being proved false. And testability, there is some real hope of establishing whether it is true or false, a grounding in empirical evidence, the use of the scientific method. Empiricism, and, later, positivism and logical positivism, grounded science in observation, and campaigned for a systematic reduction of all human knowledge to logical and scientific foundations. Non-science, metaphysics and philosophy of religion, on the other hand, was non-observational and hence meaningless, a theory also known as verificationism. Karl Popper, in response to the logical positivists, recognized that a theory might well be meaningful without being scientific, and that the central feature of science was that it aims at falsifiable claims, claims that can be proven false, at least in theory, which he called falsificationism. The American Thomas Kuhn pointed out that most science was what he called normal science, problem-solving work within the bounds of current theory and knowledge. However, when many anomalies are generated during the process of doing normal science, it may become accepted that the work is actually extraordinary, or revolutionary, science within the current scientific paradigm. There may then occur a paradigm shift, such as the shift from Newtonian science to Einsteinian science, until the new paradigm is accepted as the norm by the scientific community and integrated into their previous work. Kuhn argued that a new paradigm is accepted mainly because it has a superior ability to solve problems that arise in the process of doing normal science, and pseudoscience or non-science can then be defined by a failure to provide explanations within such a paradigm. In this way, science progresses not just by gradually building on the works of the past as had always been assumed, but by a series of revolutions in which the ways of thinking in the scientific community are changed completely. Kuhn's 1962 book, The Structure of Scientific Revolutions, was hugely popular, and remains one of philosophy's most cited works. It has been called by some the most influential work of philosophy in the latter half of the 20th century. Paul Feyerabend argued that science does not occupy a special place in terms of either its logic or method, and that there is no method within the history of scientific practice which has not been violated at some point in the advancing of scientific knowledge, so that any claim to special authority made by scientists cannot be upheld.